Well, my friends, today we're going to be taking a look at an array as a parameter, lesson 202. Basically, we're going to build off of what you did yesterday with arrays and try and expand into how you might be able to use them with methods. Maybe at the same time giving yourself a little bit of an objects review. Okay, so array ops starts us off. That's not really where I want to focus because it doesn't have a main. So I hop down here to array demo, and that's where my main is. First thing I do inside my main is construct array ops operate. So I'm instantiating this array ops object with the name operate. Note the fact that my array ops does not have a constructor. That's okay because this empty constructor I get for free. So I don't really need to do anything fancy with that. So array 1, I use an initializer list and I make myself an array. Down here I get the array is. I'm going to go into the operate object up top. I'm going to call the array toString method and I'm going to feed it AR1. The huge thing to note at this point is that this AR1 points to this list of numbers. X, because it is my parameter, is actually going to point to the exact same slide, the exact same array. So array 1 is this list of numbers. X is this same list of numbers. Anything I do to X affects AR1. Anything I do to AR1 affects X. They are the exact same list at this moment. Inside the method, I have this for loop. If s.length is greater than 1, I'm going to throw in a comma. Otherwise, I'm just going to add in the value. So essentially what this is going to do is it's going to take my array and turn it into a string. This is nice because the array does not have any built-in toString method. If I tried to put AR1 here directly, I would get some gobbledygook, like some numbers and letters and add symbols. It's not at all what I'm looking for. So this method is really helpful because it allows me to visualize what's inside the array. Whether the program asks for it or not, it might be nice for debugging purposes to be able to look at what's inside my array. So I might get a lot of use out of this method, and that might be why it's put inside this array ops. So I kind of have my own toolbox of skills that I might want to use. Alright, so another example. Here I have a main. I have an array of characters instead of numbers. So note the characters get the single quotes. So I've got comp sci inside my array. Then I have this this print line, A occurred, count letters, stuff. Now note, I did not instantiate an object. Instead of making a separate object, this is actually a local method. It's right here in the class that I'm working in. I can tell that because there's no dot operator, so I know I'm not looking in another class. It's local. Also note, to make it local with my main, I have to make it static. Otherwise, JCreator will yell at me about static reference from a non-static context. It needs to be static because main is static. So all the methods that are housed that I want to use locally should be static. So my method's called count letters. It's referring to this array letters, which are all these guys, which down here I'm calling data. But data and letters are pointing to the same information. It's also accepting a second parameter, just a single character, A. So target now has an A in it. I have a loop, instantiate a count, a for, data I equals target, letter plus plus. So basically I just want to tally every single time this letter occurred inside the array. So this will say A occurred 0 times because there are no A's in my list. Again, notice the power of a method. Rather than repeating this exact same code for C, I can just put it into a method and then call it a second time with C. At the center of their soul, programmers are lazy. We want to try and optimize our time and optimize our code. If you find yourself copying and pasting a whole lot, there's probably a more efficient way to do it. So I'm going to tally up my C's, and it's going to tell me that C occurred 2 times. Down here I make a new character variable. I'm going to call that A. I have a for loop. A for loop looks pretty simple straight off the bat. C is 0, C is less than 26, C++. But then something weird occurred. In this advancement part of the for loop, I get a comma. So this is actually saying at each pass of the loop, C will go up 1, but let will go up 1 also. Just to make it even weirder, not only am I having 2 things advance, one of those things I'm advancing is a character. I can actually say let plus plus, and it'll turn this A into a B. And then when B plus plus will turn the B into a C, and it'll actually jump to the next character in the sequence. It's kind of weird, but you can interact with letters the same way you interact with numbers. So I'm going to say whatever letter, in this case A, I'm going to say it occurred, count letters, I'm going to pass it the array and the letter, so it'll do a tally, and then times. To try and do this without a method would be really, really cumbersome, to be able to try and pull it off with all the variables swimming around. So this method really allows me to replicate the same thing many times. New example. In this example, it's kind of AP style, where they're going to have this nums array populate from reading a file. This is not really a real method. It's just for fun. The AP is reading it in from a different source. Then I'm going to print nth nums comma 3. So what this is going to do, it's going to call this print nth method. Again, there's no object, so I'm looking local. It's going to accept the array, which is R, which has some data in it. I have no idea what the data is, but it's got data. And then it's going to accept some number as the second parameter. I've got a string, I've got a for loop. Looks pretty straightforward, the 0 less than length. Note that this is an I plus equal n. If you're reading a multiple choice question on a for loop, be very careful of the increment, because it can make a world of difference to how the problem operates. So we're actually going to grab every nth number in the pattern. We grab the ith spot of the array, throw in a space, and accumulate that all into a string. In the end, it's void. It's just going to system out that print line what we've collected. So essentially this nums3 is going to grab every third number. So we're going to grab 0, 3, 6, 9, indefinitely depending on how big the array is. This 110, unless we're getting a really big array, that might just be a swing and a miss. If we're trying to grab, we'll grab the 0 spot, but then when we try and grab the 110th spot, if that's bigger than the array, this just won't trigger. So that might very well just print spot 0. But I have no idea. The array could hold 10 million spots, and maybe the 110 will be helpful. But it's not going to cause any problems. There will be no exceptions. It just might not be all that interesting. All right, so we get a multiple choice question. Precondition, they're telling us it's a non-empty list, just to avoid any flags that might happen. Max takes on list.length minus 1. Looks like I made a typo and I forgot a semicolon. We got a standard for loop, and then if list k is less than list k plus 1. So what this is claiming is the number in spot k is smaller than the number in the next spot. We're going to follow these next 3 lines. These next 3 lines are kind of a classic swap. So it's basically just going to be having them trade spots. If you don't use this temp, then swaps get ugly. You're going to learn a lot about swaps later on in the course. So we do a trade. If k is smaller than k plus 1, we're going to trade spots. And then we're going to keep looping all the way through the loop and let k advance and follow that same rule. Once all said and done, basically we're saying if the number that comes first is smaller, I'm going to trade them. This small number in the beginning is slowly going to get pushed further and further back to the end of the array, so that the last number in the array is the smallest value. I think that's exactly what A is saying. Alright, so that's really all you need to know about arrays and methods. I want to give you a little bit of a heads up on today's lab, because if you know what you're doing, then it's not all that bad, but if you don't know what you're doing, it can be pretty horrible. To do that, we need to first understand what the sieve of Aristophanes is trying to do. Basically, the logic of the sieve of Aristophanes is you take a number like 2, and you take a list of numbers, and you cross out all the multiples of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. What we're doing is we're trying to look for primes, and our argument being if you cross out all the multiples of 2, such as 4, 6, and 8, they can't be primes because they have 2 as a factor. You then go to the next number. So our multiples of 3 are going to be 6. Again, I want to cross that out. 9, 12 again, 15, and then 18 again. We don't really need to do 4 because 4 is already covered by 2. For our program, we'll probably run 4 anyway, just because it's not hurting anything. So our 5s, 10's already crossed out, 15's already crossed out. And you notice, after 3 passes through, we get a pretty decent list of primes. Going through. What I would suggest to do to try and automate the idea of this is if you have your array, I don't know how big I really want to make this, but I'll just go out to maybe 10. If you've got your array, and I always get this wrong as to whether or not I had you initialize it to trues or falses, but let's just assume that they're all trues. If they're all trues starting off, what you could do is 1's not going to be all that important because 1's not a prime. So I would start with 2. I would do 2 times 1, actually 2 times 2 would be a better start because you want to leave 2 a prime, and get 4. Go to that 4 spot and change it. 2 times 3, go to that 6 spot and change it. 2 times 4, go to that 8 spot and change it. 2 times 5, go to that 10 spot and change it. When you try and do 2 times 6, it's too big. So that's the signal that you're going to be done the loop. What you then want to do is turn around and then try the next number. 3 times 2. 3 times 2 is 6. Go to that spot and change it. Note, 6 was already changed, but the algorithm to try and make this run faster by avoiding collisions is a lot more work. If you want to go for that, you're welcome to, but that's not what the requirement's asking for. I'm just asking that you run the algorithm. 3 times 3 is 9. Change it. 3 times 4 is too big. So next we go to 4 times 2. Now, hopefully at this point you see the nature of a nested loop. My first outside loop will control the front number, 2, 3, and then 4. My next inside loop will control the in number, 2 through whatever. And you just keep going while this product is in bounds. As long as this product is in bounds, you can keep going. Hopefully it's giving you enough advice to be able to get started on the lab. Otherwise, you might want to hunt for somebody in the class who's already had comp sci 2. Best of luck, you.